Hello and welcome to my very first Math Monday. I'm so excited you decided to join me here. Today, for my very first Math Monday, I thought it would be most natural to talk about sigma, seeing as my name is Sigma of Sarah. This so far has just been this inside joke between me and all the math nerds here, but I want to bring everybody into the fray because there is no room for exclusivity here, only inclusivity. So let's talk about sigma and what it means. This is what a sigma is. It looks something like this. It's a Greek letter. We often use Greek letter in mathematics because the Greeks laid all the foundations. So we kind of just kept using them. So what's sigma used for? Sigma is used to say the summation or the sum, to sum up a bunch of things. So say I want to add a big line of stuff, but I don't want to have to write it all down, then I'd use sigma notation. So, for example, say I want to sum all the even numbers from 1 to 100. All right, so what I would do here is I would write sigma of 2n, so sigma means sum, and I want n to be any number from 1 all the way up to 50. All right, 50, not 100, because 2 times 50 is 100, right? So that is basically telling me to go start at 1, so 2 times 1 is 2, right? And then keep going up by 1 until you get to 50. So 2 times 2 is 4, 2 times 3 is 6, all right? And then I just keep going until I'm at 50. So 2 times 49, that's 98, plus 2 times 50 is 100. So this thing here is showing me or telling me to sum all the even numbers from 1 to 100. So what if I want to sum all the odd numbers from 1 to 100? Well, I'd take 2n minus 1, because you have 2n an even number, you subtract 1, you have an odd number, right? I'm still going to keep that from n equals 1 all the way up to 50. All right, so then we substitute all the numbers in for n from 1 to 50. 2 times 1 minus 1 is 1. 2 times 2, 4, minus 1 is 3. And 2 times 3, 6, minus 1 is 5. You just keep going until you get to 50. So 2 times 49 is 98, minus 1 is 99. And 2 times 50 minus 1 is 99. All right, so that's just telling us, okay, add all the odd numbers from 1 to 100. So I'm going to talk about a really specific situation, and that is the sum of the first 100 numbers. So this is how I'd write it, just the sum of n, or sigma of n, where n is equal to 1 to 100. So that's 1 plus 2 plus 3 all the way up to 98 plus 99 plus 100, right? So there was this mathematician named Gauss, and what happened is his teacher, when he was only 10, kind of just wanted to get rid of him for a while. She was said to be not very nice, so she just said, go sum the first 100 numbers, expecting it to take him a long time and to give her some peace and quiet. That's how the story goes, at least. But what happened is Gauss came back a few minutes later and had the sum of 1 to 100. He had the whole thing done and had the correct answer. So we're going to figure out how he did that. So here I have the sum of 1 to 100. What if I sum it in the opposite order? So 100 plus 99 plus 98 all the way down to 3 plus 2 plus 1. Is that going to get me a different sum than the top line? No. It doesn't matter what order you add things in as long as you're adding the same things together. Right, so this top line is equal to what I'm going to call S for the sum, and so is the bottom. And they're both equal to S, the sum of the first 100 natural numbers. So what if I add these together vertically, not horizontally? So for example, 1 plus 100, that's 101, right? All right, so let's keep going. Then we get 2 plus 99, that's 101 again. That's then 3 plus 98, oh my goodness, it's 101 again. I think you see a pattern here. We'll go all the way and we'll just keep getting 101 until we get to the end. So 98 plus 3 is 101, 99 plus 2, 100 plus 1, all 101. So what's happening is that we have 101 added together 100 times because, of course, there's 100 numbers. So of course that's not equal to s, that's equal to 2 times s because you're adding s to itself. What I also found out is that 2 times s is then equal to 100 times 101 because you're adding 101 together 100 times. So to get s, all we really need to do is divide by 2. So we'd have 100 times 101 divided by 2, right? That's actually equal to 5,050. So there you go. Next party trick, you can just go up to anybody, hey, do you know the sum of the first 100 numbers? And they'll be, well, you'll be able to tell them. They probably will have no idea unless they've also watched this video. All right, so I know what you're going to ask next. Can I sum the numbers, the first 1,000 numbers, or the first 1,246,253 numbers? The answer is yes, you can. There's a general formula that we can derive using Gauss' method here. So what that is say I want to add the first n numbers, where we're going all the way from n is equal to 1 to any number n. So that's what we're just going to say. Well, if that's n is our top limit, if we look at what we did with our top limit of 100, we took it, we multiplied it by 100 plus 1, or 100 plus, or 101, so 100 plus 1. All right, so we can do the same thing here. We take n, we multiply it by n plus 1, and of course we had to divide it by 2, but there you go. That's going to get you the sum of the first however many numbers you want, which is awesome. So that's the shortcut. So if you want to find the sum of the first 5,243 numbers, substitute 5,243 in for n, and you got your sum. Thanks. If you have any questions, please comment below or DM me. I hope you guys have an awesome Monday. Thanks for watching.